Hi everyone, welcome to MathSpellBook. I'm your host Peter, and we are going to engage with vectors today. Hello, Ferris. Hopefully I pronounced that right. It's either Ferris or Faris. Hopefully I pronounced that right. But how are you doing? What's the best part of your day so far? But anyway, let us get into it for today. Hopefully you guys are doing well. It's Monday, and of course Monday is usually like those days when you just have to be productive. So I thought I would like actually just start reviewing what I know about quadravariant and covariant components for vectors. It is fair, so you actually got it. Okay, cool. That's good. What's the best part of your day so far, Ferris? And what are you up to right now while you're chilling with us on the stream? Oh, thank you. Really appreciate that. And plus you're awake to enjoy the day. That's also another one. Usually when I ask that question, people are like, I don't know what's the best part of my day. And I basically say, well, you woke up. That's one thing. People always forget that. They always forget, like, oh, I woke up to experience the day. Gotta count that. So what I know about what I'm familiar with quadravariant and covariant components is that I always recall back to, where's the diagram? Because I've read this book. Like, this book is usually like my go-to for like trying to understand deeper about this stuff. Where is it? Here it is. So basically, I know covariant is basically related to the grid itself, whilst the quadravariant is basically related to the vector. Like the vector. Well, not the vector itself, because the vector is supposed to be a thing that doesn't change. I think it's basically I guess you can say the perspective of where it's being measured. Because I know they work like sort of like opposite of each other, but at the same time, like there are components to it. The one thing is that I know you have to write the vectors in these form, and what I learned is that basically with the way to get, I guess, I don't know if it's like the metric tensor involving them, but I know once you have these in a matrix, the basis vectors here. So I think these are covariant. Yeah, these are covariant because it's lower. So what I remember is that the covariants, like if you have these basis vectors and you put them in a matrix, that would basically be, I think that would be the metric tensor revolving around this particular setup. But then I'm still trying to find the connection between the metric tensor and the covariant and the quadravariant components. I should just like look at the questions here. I should have just clicked this. Let's see, write the inverse transformation of 70 degrees rotation of a 2D Cartesian axis and the indirect transformation matrix for the rotation of the vector through the It's okay. It's okay. I'm just basically re-saying what I remember. That's all. Like, even if you guys like are new to you know, this type of math, like, don't worry about not understanding stuff, because sometimes I don't understand it either. You're still 14. Well, you know, like, I mean, like, I'm guessing you click on the channel because you like math, right? But I'm trying to find a place to learn to advance. Yeah, that's good. That's good. At least you're challenging yourself. That's usually a plus, because I didn't challenge myself for a long time when I was younger, and you know, it shows how much like I'm still lacking when it comes to like experience and skills. So you know, like it's good to challenge yourself while you're young. Okay, so I think we can. So I think we'll just take this first question here, right here, and then I'll copy it. I just left these notes here for like if we want to do Maxwell's equations later. They're not really notes, they're just basically stuff from the book that I wanted to keep in mind separately, so in case if I wanted to go back to it. Paste. Expand this like that. And also, if you guys are watching this on YouTube, welcome. I just want to double check to make sure that the live stream is on YouTube, just so that both streams are going on pretty well. So is there a way to get my higher grades curriculum? Usually there is. Okay, I think we are live because I do click on my channel and I see that there's a live icon here. I'm just gonna click on it to see. Okay, cool. We are streaming, so that is good to know. I'm pretty sure you can look online because like what math courses are you taking right now? Do you know? Like I mean like currently, like what you're studying in school. Oh wait, hold on, it's the summer though. Unless you're going to school like during summer school. Because usually if it's like algebra, you would probably more likely take geometry. I've gotten all hundreds, but not only my math class, but I find my math class to be the highest potential. Yeah, it is summer, yeah. Like, do you remember what you last learned in your math courses? Maybe that will give me a clue. So, write the transverse transformation of 70 and the Cartesian axis at the indirect transformation. Show that the product of these two transformations is the identity matrix. Oh, okay. That sounds like an idea. So I'm guessing the transformation matrix they're talking about is this. I believe it's cosine and negative sine and then sine and then cosine. Oops. And then another cosine down here. And I believe the other one is the opposite. Like you do it like this. Well, I don't mean opposite, but I think in linear algebra they call it the adjunct. I think it's the adjunct version. I take everything. I'm in Cambridge. Algebra, geometry, statistics, and probability. Okay, so those are the last math courses you took. So I think the next thing you're going to be taking is pre-calculus. Usually pre-calculus is like next after those. If you plan to take calculus. Okay, so it says 70 degrees. I'm gonna actually try this. Oh, hello. Idea? Welcome, welcome, welcome. Welcome from YouTube, actually. What's the best part of your day so far, Idea? Sorry if I mispronounced your name. Like, tell me how to pronounce it correctly if I'm mispronouncing it. Okay, so... Okay, I think we got that, so... Okay, second sine 7 degrees. Really? You're not giving me the decimal places? Enter to save it. Okay. Alright, let's see. Let's try this again. Okay, why is it giving me in sign notation? That's not what I want to see. Alright, forget that. I'll just do it from my calculator I have at hand. So... just do it by 3 digits. And I'm guessing this will be the same thing. Now we have to prove that they are the identity matrix. So technically they should be. I don't think technically we have to write out the numbers when I think about it. Because when you think about it, like... I think the reason why I wrote them out is because they went to a specific number. Like, I mean, they put 70 degrees. But in actuality... plus because you will still get the same thing. And the next side, the way this turns out, I think it's pretty obvious because these two will equal to 1 because, like, you know, cosine squared plus sine squared will equal to 1. These two are just basically equal to each other, but this one's as a negative sign, so basically it will go to 0. And this is the same thing, so I think that's pretty obvious right here, because then the next one we're going to be getting, yeah, we're going to get sine of 70 here, and then sine of 70 degrees here, and then, yeah, because then sine, and then cosine of 70 here, and then cosine of 70 over here. And we all know that basically, regardless of what theta is or the angle, it's always going to equal to 1. And like these will equal to 0 because this one's the negative version of this. So I think we have shown that they're all equal to the identity matrix. So I think that one was pretty easy. I think we have the, yeah, here we go. Here. Yep, we didn't even have to write this out. We just had to basically just make sure we put the right places. Yeah, because that's the way the inverse looks like. So I think we did pretty good on that one. So the next one, use the inverse transformation matrix from problem 4.1 to find the component vector in the rotated coordinate system. Okay, so we have A so we have to use the transformation one, so I believe that is cosine sine of theta, negative sine of theta in the second row, and cosine theta. Okay. Now, because this one revolves around the original, which is cosine sine of theta, and oops. So now so I think we have to basically calculate the hypotenuse of this. So alright, type that in my calculator. 4 plus, let's use this with 5.85. So I think we gotta figure out the angle, what theta is. So theta, we can choose any one of these. So I guess we'll choose cosine. Over hypotenuse. So that leaves us with 70.70 degrees. Now, if I remember the way that these work, usually vector A would be represented by, let's see, A as the x component, to E1. Actually, that's going to be a little confusing. So it's primarily 70 degrees, so I think what we have to do is that that's what you have to do, because if we just split these, then, but the one thing is that I mean, we're not in quadravariant coordinates yet, so I don't think that we have to worry about that, but still could be. sign there. Oh, hello, Studymatics. Nice name. I actually like that name. Which classes, I'm guessing which classes is for. This is not for a class, this is just me, like, self-studying stuff. So it mainly revolves around vectors, so if you think of it as, like, being part of, like, linear algebra, like, I guess it's more fitted towards, like, linear algebra if you think about it. But it can also be you can also take it, like, in, multivariable calculus. Like, the way I study, I don't think of classes, I just think of subjects. I just basically just pick the subject that I feel is right. I mean, if you add these together... its course of I'm not sure what you mean by the last part. It's a course of ITG. I don't know what that means. Or ITG. Let's see, use the inverse matrix from problem 4.1. Oh, entrance exams of India. Oh, okay. I see. Oh, engineering. Okay. I see. So I'm guessing, like, you study engineering, Studymatics? Engineering is a pretty tough field, though, I'm not gonna lie, because you have to know how to build stuff, and you also have to know, like, you know, the basics of, like, physics and mathematics, too. So, it's not an easy field. Actually, like, if I were to be an experimental physicist, I would have, like, just, I would have probably just, like, do engineering courses just so that I know how to build things. But of course, I'm not in school, though. I'm just basically just doing math and physics as a hobby, as I've let you guys know. And also, guys, if you're tuning into either the YouTube live stream for the first time, if you're tuning in the YouTube live stream for the first time, you know, consider dropping a sub if you can, because it always motivates me to continue streaming more math/physics content for you guys whenever I feel like I need to study more on the subjects. Preparing for this? Oh, okay, cool. I mean, hopefully, like, my struggles in both subjects will help you in your endeavors, Studymatics. No, I'm not. I'm just really into math and physics as a hobby. So I basically try to, like, do these streams to basically get myself into a study mood and to practice. And to learn more about, like, the stuff that I feel like I I guess, memorize from the book, but then try to solidify it in a way where it feels intuitive to me. So develop my own study, my own way of learning the material by interacting with it. I mean, I do like to help out people that need a little help with math, like if I know it. I think like the amount of math I know is like Calculus 1, but I do know bits and pieces of Calculus 3 and bits and pieces of Calc 2, but Calc 2 I have to relearn a lot because the integration techniques sometimes I always forget. I think integration by parts I remember the most, but I don't remember that much on like trig substitution and series that much. Oh yeah, we were doing this problem, so... So is this the correct way of actually doing this approach? Because I know we have to turn this with the transformation of this. And what I learned from linear algebra is that you can kind of consider these as sort of like the basis vectors if you just split them. But I don't know if you're supposed to do it by row or you're supposed to do it by column or you're supposed to do it by row. Because I don't think we hit the covariant and the quadravariant components yet. So I'm thinking you're supposed to do it by column. Because I think when you get into covariant, you're supposed to do it by row. And I think this would probably be the vector we're looking for. So I think we'll check to see if I did it right, and if we didn't, we'll just learn something. Okay, so problem 4.2. Let's take a look. No, we didn't do it right. So what they do here? Okay, they did multiply this, okay. Oh, okay, this is the way you're supposed to do it. Okay. Okay, yeah, that's the way you're supposed to do it, alright. Well, that's something I learned. Because, like, I think what I was trying to do here was trying to implement what I learned from linear algebra, but I guess I wasn't doing the right method here. But that's something that I should note. So the way they did it was that you're supposed to use this and just multiply the vector in there. Okay. So it's 70 degrees. And the way they set it up was that you're supposed to have the vectors here. Then basically you're supposed to do it like so. 2 times that. And then sine. And then negative 2. Sine of 70 plus cosine of 70. Using matrix in vector, how do you find the value of cosine? So what I did was that I basically just I did like Pythagoras' theorem right here, and basically got like the hypotenuse of these two vectors, and then basically, well, the distance actually, and then basically did the inverse cosine here. That's how I got the angle. 70 plus. I'm doing the calculations on my calculator by hand, guys. So unfortunately you can't see when I'm doing the calculations. Which I think is what we get, and then minus 70 degrees plus cosine 70. And it's like 0.001, and I think they rounded it up to 0, or rounded down to 0 actually. Okay, so we just got to remember that whenever we do like a linear transformation, like I think they wanted it to be done like a linear transformation like this. So this is what I've learned. I remember this is a linear transformation, but I guess I got mixed up on which methods I should employ. So that's probably something I have to keep in mind. Okay, so this, then we'll move it over here. I will get answers wrong sometimes, guys. Just be aware of that, because the thing of it is that like sometimes, like in order to like truly learn, I have to be able to like remember stuff that I have kind of like learned, like what I've learned, and then try to implement it in problems. And sometimes like I hate it when like you go through a textbook and you learn like everything the textbook tells you, but at the same time like you learn everything in the chapter that it tells you and you feel like you know what the routine is, like you're supposed to learn how to do it from the book, but at the same time I also try to like make sure that I expand more, so I use the knowledge that I don't really implement as much, so you know. Oh, I'm glad that you're also a lover of math, studymatics. That's good. That's good. do you know Monica? Hi Denison. How's it going? What's the best part of your day so far? Oh, hello, Zach. How's it going? Actually, Zach, I'll give you a shout out. Oh, you're replying to what Ferris said. Okay. Because I'm actually looking at a multi-chat, guys, so I'm looking at what you guys type on YouTube and on Twitch. So on the multi-chat, it doesn't show me that you replied to someone. But Zach, how's it going? What's the best part of your day so far, my friend? If you guys are not familiar with Zach, on Twitch, let me see here. Let me just give you a proper shout out here. Okay, cool. Hold on, does this lead to your channel, Zach? Oh no, this leads to mine. What the heck happened? That's not supposed to happen. Did I type your... Oh, I forgot the I. Oops. I knew something was up. I was like, why did it lead to my channel? That's not supposed to happen. But if you guys are not familiar with Zach, if you're on the Twitch chat, he is an awesome mathematician himself, as well as he streams math and also answers your math questions, because he's just a straight up awesome teacher. So be sure to check out his stuff. There we go. I was like, that's not right. I'm not trying to lead them double lead to my channel. I'm trying to lead them to your channel, Zach, because you definitely deserve it. Been trying my next set of streams together. Oh, okay. Trying to organize things. That's fair. That's fair. Okay, so where were we? Oh yeah, I think we were on number 3. Use the direct transformation matrix from problem 4.1 to rotate the original coordinate basis. Oh, okay. By 70 degrees. Okay. All right. Fine. So we have to do this. So cosine, and I think this is negative sine, and then sine 70 cosine. How can we increase math solving ability? Just doing more problems, I think. But also, like, I think for me, it's like, when you do math, it's like a muscle, but a lot of people try to strain that mathematical muscle for me, I try not to strain it because like if I strain it, then I get so bored. Like I would say like you just do like problems. Like I would say like the most I would do with problems on a certain subject is probably 3 problems. And you know, like that might be not enough, but I try to do like at least 3 problems a day, whether it be like on a one subject or many of them. And then like you just let your mind wander, and then I just basically let my mind wander, and if I have a mathematical curiosity, I would look it up and I would try to understand it to the best of my ability. Not really solving problems, but try to understand what exactly the content is. That's what keeps me inspired mainly. Because I think what people worry about with math is that they feel like they have to be a constant problem solver. And like that's not a bad thing, but at the same time it's like there's more to math than just solving problems. Like, I mean, once you are able to solve a problem, then you have to ask yourself what it means. And sometimes answering what that means is not vaguely clear. So the basis vectors I and j. So we're just going to consider that as 1. I mean, technically, when you think about it, though, it's like you're just basically doing m plus negative sine of 70. Honestly, I don't want to write their decimal representation, so again so we make sure. Why by quadravariant components? What did you mean by what the last thing you wrote, Dennison? WDYM? Or were you typing? What do you mean? Is that what you shortened it to? Because that's a use the direct transformation matrix from problem 1.4.1 to rotate the original coordinate basis vectors I and j by 70 degrees, so they point along the axis, rotated axis. I feel like we did that right, because like I and j are supposed to be unit vectors, so check out the hints, because maybe... Oh, okay. They wanted us to do it this way. Because when I think about it, this will probably be the same thing, because it's like, ends up like that, ends up like that. Because if you do this, then basically you end up with 1, and then 1 over here, so lay up like that, and then let's see what happens if we do it that way. Because I think if you do it that way, then basically you would be left with 0 right here. Opposite, it would be negative sine of 70 here. And then if it's at 0, so that means sine of 70 here. And technically it would probably be like the same thing, like going on the logic that I'm thinking about. Let's take a look. Oh, so you have to do it this way. Okay. So it's just separate, like, it's just separate components. Okay. So this would be like this under the transformation, and this is J under the transformation. I think I'm mixing them up with linear transformations. That's the reason why I keep, like, fouling up the answers here. That's another thing when you self-study, is like you learn like all these different techniques from, like, I think different branches, but then because I guess I kind of have information overload, I'm kind of implementing them when they shouldn't be implemented. Because the way this is done, because it says use the inverse to find the components. And yeah, so we were given the vector here, and this one to rotate the original coordinate basis. Okay, maybe that's the reason. See, because it says find the components of the vector from the rotated, and this one is supposed to be rotate the original coordinate basis vector by 70 degrees so they point along the rotation of axis. So I has to be 1 over 1, 0. This one has to be 0 over 1. So I guess we have to treat these as like separate vectors of their own. Okay, so I have to keep that in mind. And they are technically like basis slash unit vectors, so it makes sense that they would be like this. Alright. But, you know, the more questions we get wrong, like the much more we learn. And that's what matters. Okay, use direct transformation matrix to rotate vector A from problem 4 point. Okay, so the vector we had then was A is equal to 2. Is 2I plus 5.5 J. Okay. Alright. So through the angle of -70, okay. The direct transformation matrix, okay, so the direct transformation matrix is this one. Compare the x and y components of the rotated vector in the original coordinate system to the x prime and y prime components of the unrotated vector in the rotated coordinate system. Of the unrotated vector in the rotated system. So I'm guessing that these components are in the unrotated system, whilst the ones that we want to calculate are the ones in the new one. So let's calculate this. So okay, and the next one. So now it says compare the x and y coordinate of the rotated vector, which I'm guessing is this one, in the original coordinate system to the... Oh, okay. So I'm guessing with the they say the rotated coordinate system. So I'm guessing they want us to do the other transformation, which is this one. No, not this one. This one. Because I think when we did it for this one, it's about the same. Yeah, they're about the same. Because this is minus 70, and this one's just 70. That's anything to do with it. Let's see, what does hint 1 tell us? Yeah, we did that part. Yeah, we did that. So what is the full solution here? These components rotated as expressed in the original non-rotated coordinate system. They are identical to the components of the original non-rotated. So the way they wrote it, like this, like that, yeah, we did the same thing. They are identical to the original non-rotated vector expressed by rotated. Okay. Shown in problem 2.4. Yeah, they look the same. Wonder if that's has something to do with I wonder if that has something to do with like some sort of symmetry. It says use the dot product of the original vector A with the rotated basis vector. Find the components of A in the rotated coordinate system. So are they still making us use a previous problem as reference, or we're just doing it through like just a regular vector called A? Dot product of the original vector A with the rotated basis vector. Transformation, new basis vectors. System coordinate rotate. Use the dot product of the original vector A. just thinking of A as like this. Okay, find the component of A in the rotated coordinate system. Trying to think about like what is so I'm guessing maybe they want us to do, let's say, rotated coordinate system. Set it up like this. Find the components of A in the rotated coordinate system. So, if that's the case, we're going to have looks like they want us to use the same angle. So they want us to use the same vector. Yeah, so it's supposed to be. I wish they would just reference the number. Like reference the actual question number that we were working with. And the angle, I think, is supposed to be 70. Do the calculations. So the wrong transformation matrix. Probably did. Let me see. Yeah, I think I did. Because I think this one is supposed to be the -1. Let's see, rotated. Okay, so I think this one, I think I wrote the wrong rotation matrix here. This is not right, and this is not right. So I think this has to be this. Oops. Yeah, usually this is like the struggle. It's like basically trying to make sure that you answer the question correctly or know what the question is asking. So I think we're on number 6. Okay, so let's see, for vector, the basis vectors are, okay, so they're quadravariant basis vectors. Find the covariant, find the contravariant components. Okay. And we have vector A here. Because I remember the way you wrote a vector, or at least is usually like AX. Because usually the basis vectors, like the basis vectors kind of act as kind of like opposite components, because because vector A is supposed to be the same in both cases. Because this one is basically the quadravariant components, or basis vectors, I should say, the quadravariant basis vectors. And I know, like, when you also write it in this way, I'm thinking about it is that and I think at this point for this. I remember like with ChatGPT, I was asking questions on whether the like when you do covariant and quadravariant vectors or basis vectors or the components, I asked it, it's like, oh, what would happen if you basically turn all the basis vectors, like whatever components it'd be, into like just a matrix, and you basically did the inverse of that matrix? Would that give you the other components of it, whether it be quadravariant or covariant? And I think with like ChatGPT, it basically said like it sort of leads you to that path, but you have to also remember that so these are like more like row components, so they basically lined up in a row like this. But when you actually do for the other way, it's basically like columns. So in this case, this is probably not a part of the original question, but I thought I would just play just play around with the math and see how it goes. Basically, since this is considered like the inverse, like the way that the components would look like, because this one, Contravariant is supposed to be like rows. Yeah, this is what sometimes happens to me. I have a thought and I just basically try to play around with it, see how it goes. But now I'm thinking about it for a brief second and I'm like, maybe that's not the right way to approach it. But sometimes, like, when you learn like new stuff, it's like, for me, I just want to try to implement it and see if I can use it. But I don't think it will be useful to like implement what I'm thinking about right now in this scenario. I don't know if you guys ever had that experience when you're doing like homework and then like you basically are like, I'm curious about this idea. Maybe I should play around with it. Because sometimes it's good to do that. Because it kind of makes you feel like you're engaging more with the material, even though it's not actually part of the homework. Like, even though I got a lot of stuff wrong in this stream, I have to say that, like, basically it's like all about just reflecting on what I learned here. Cause I think the reason why I got like these questions wrong is because I probably don't fully understand exactly what it's asking. Because I do get the part where it says like inverse transformation matrix, which is this. Because they're kind of like, it was self-explanatory. I think the reason why I got this wrong was because I didn't set up the vector correctly. But then like it's written like this, so I'm thinking like, oh, like this is how we're like taught in linear algebra about linear transformations. Like this proper setup here. And then in this one it said use the direct transformation matrix to rotate the original basis vectors. Now this one, I didn't realize that we had to separate these unit vectors, because I was thinking of them as just like related to one vector, but they're actually like separate vectors, which should be written like this, and then we had to write them like this. This one I think I got a little bit confused about. Let's see, what did they write here? Because they said inverse transformation. But in this one, I think I got a little bit messed up here because they said with rotated basis vectors. And I think that was the thing that kind of got me mixed up, because the previous problems, they referenced a problem, like a previous problem like 4.1 or 4.2. But this one, they didn't reference any problem. But then they expect you to take the results from the previous problem into this part, which I thought was kind of like, which I thought we were supposed to make like a new vector. Alright, so let's reread this again for vector A, and the basis vectors. Find the quadravariant components A1 and A2. I think for like, since they're covariant, because the way they're written, it looks like it's supposed to be like, these are quadravariant components. Although the way they're written, like sometimes, like since I don't have the physical book, sometimes like I'm worried that they wrote like the way the typefacing is, like they could have meant quadravariant. I mean, covariant components. But if it's like covariant, it's supposed to be lower. Let me check here. Okay, yeah, they wrote it like this. Okay. Luckily, we checked here. So it is it's covariant components. So if it's covariant components, then that means that these should be in a row. So it's 1, 2. Let's try this. Okay, that'll be 12 minus 5, 7, 10, minus 6. I think that's correct. Let's take a look. Hint 1. How did we wrote it here? The way they do it is like solving for like linear equations here, and I'm guessing the way they wrote the matrices is like I think we didn't do something right here, so this wouldn't be correct. So, like the way they aligned it was like that, and then like this, because I think this row is supposed to be the eyes, and I think we also have to erase this part right here. So 1, 2, there we go. Alright, so I think like in linear algebra you would do the approach that I did before. Just like do it like this to get like the inverse on this side. Now, let's see if that is actually what A1 and A2 are. Oh, they did it in a different way. Oh, they use Kramer's rule. I didn't learn that in linear algebra yet. I'm familiar with it, but I didn't learn it. Hey Sasha, how's it going? What's the best part of your day so far, my friend? Yeah, I'm actually like getting a lot of problems wrong. It's like just one of those days. I'm not down about it. It's just like, you know, it just feels like, wow, like I'm actually like not doing so well here. I think it's because like I know, like I've learned like many different concepts. I just didn't like organize them well in my head. Because I thought we could do a linear transformation over here. But I guess that was probably not what I was... Oh, you're done writing it? Nice. Awesome. When do you have to submit it? But you guys basically are getting everything with every stream. Whenever I have really large amounts of like questions I do completely incorrectly, or whether I just do some questions correctly and some questions completely wrong. That's the struggle. That's the struggle. But I have to be willing to submit those. I want to submit it on at most Thursday. Oh, okay. I'm pretty sure they will be impressed with what you have to submit to them. I mean, you've been working on that thesis for a while, so, and you've been researching it, so I'm pretty sure that your paper will be very, very impressive. At least I hope so. Let's see, what did they do in this one? So they made it into linear, yeah, they made it into separate linear equations. It's the way they set it up. It's like, because these are covariant, and they're like this. So when they're covariant, they have to look like this. And I'm guessing when they're quadravariant, they're supposed to be like rows. So they use Kramer's rule to basically figure it out. So I guess there's two ways to do it. You do it like with linear equations, or you use Kramer's rule. So with Kramer's rule, you do it like this. Okay. So probably we have to do more problems, because I think there's only 10 problems here. Yeah, there's only 10 problems. Find the dual basis vectors for problem... Okay. Yesterday I told myself I only needed 4 hours of writing to complete the whole thing. I ended up taking 11 hours and I went to bed at 7 a.m. Yeah, that's usually what happens sometimes when you're like, when you're like working on something really hard, especially if it's something you're passionate about. It takes a lot longer than you think because you see that there are a lot of errors, or there might be something that you missed and you just didn't write it down. You're learning about duality. That's pretty good. I mean, I feel as if we're kind of like just struggling by, because out of all these problems, I think I only got... I think I got this one correct, like the first one, but then the rest of them I was like, wow, I'm getting them so wrong, and I'm like, I must be missing something. Or maybe I'm not reading the directions very, the questions clearly. Because I think it's because it involves like inverse transformation matrix and a direct transformation matrix. And I think I was mixing up certain methods. Because I was actually trying to implement what I learned in linear algebra to these questions, and I didn't implement them well. So there's two ways you can do it: through system of linear equations, which I probably should have done, because that's what it probably would have been easier that way. Yeah, but this one is like totally convoluted. Okay, so I'll copy this. I'll paste it down here, and then we'll copy this. Okay. Alright, find the dual basis vectors. So they want us to find the quadravariant basis components. Okay. Now, from what I learned from ChatGPT is that, so this is basically, when you write it as a matrix, you're supposed to write it like 1 to 2. Like so. And now we're supposed to get the basis vectors. And the way I remember, because we already did this before, like, do it like this. And like, you're supposed to like transform it like this, and then, because we already did that before in the last problem. So I'm just gonna write it down, because like you guys already saw me like do that work already. Alright, so I think we have to also do something different, because, so, I think with these, like, you're supposed to write them like row vectors. Because this one is sort of like going like column vectors here. So I remember like when I went on ChatGPT, I felt like there was like a relation like with I guess the inverse of the basis vectors, and I was like, can we do that with covariant and quadravariant components? And I think like basically ChatGPT was like, you have to do it in a certain way where it's like you do have to take the inverse, but you have to write the vectors in a different way when it comes to the inverse. Now I don't know if this is the actual way to do it, but it does feel like it could be. But we'll just, because they want us to do it in this way, and I kind of feel like I don't want to go into this. Because it seems like it's like, oh, you got to do it this way with like the cosine and everything like that, and I feel like, I don't know. Seems like you want me to memorize more formulas when I probably shouldn't have to. Yeah, because now it goes into this convoluted like area of like angles and stuff. I feel like this is revolving around 1/3, not 1/5. I think I did the arithmetic wrong on the last one. I probably did. It's gonna make me do the whole thing over. Looks like I did the arithmetic right, but I guess my method was not the right method for it. But do I have to do it this way? Like, I gotta see the last problem here. Guessing you basically have to get the angle from here, like basically like doing like getting the hypotenuse here and then getting the angle. I guess you gotta use the basis vectors to like help you get to the angle here. Well, we got a lot of stuff wrong, but at the same time, we did learn some things. So I guess, like, if you guys, like, decide to do this on your own, do not do what I do. But if you're struggling with this material as much as I am, you know that you're not alone in that regard. Which is why my streams are study streams. They're not really teaching streams. Because, like, my struggle is basically for all of you guys to witness. Because we're all human, and we all lack, like, understanding at certain points. Because I think, like, the reason why I got so much stuff wrong is because I was trying to do stuff that was not in the book. But I guess the stuff I was doing was stuff that I didn't fully understand. But I thought I could do some, like, interesting, like, implementing the stuff I learned. Like, implementing the stuff I learned from, like, linear algebra and just, like, try to incorporate it in here. But I think I didn't fully, probably, like, understood what I was implementing. I think that's basically the main reason why I got a lot of stuff wrong. But I think that's usually how it is when you learn stuff. It's like you basically try to, like, implement the knowledge and you think it's gonna work, but sometimes it doesn't, and, like, you're like, oh wait, no, that's not right. But I think that's how it is with every problem, like, especially the unsolvable ones. It's like you basically think there's a method that's gonna work, and then you try to implement it, and then if it doesn't work, you're like, okay, that didn't work. But it's also hard to feel not defeated, like, after that. Because it's like, it's hard, you know, like, that's the thing about, like, I think, like, with math, it takes a lot more courage to actually do stuff outside of the book than just following the instructions to a T, because, like, you're worried about, like, doing the method right that the textbook says, but at the same time, like, it doesn't allow you to explore exactly what is it that, like, what is it that you know, and the limits of what it can do. But I definitely probably need to do more problems like these, because I would have to say that we didn't do a good job of implementing these, or at least understanding the questions. So, I mean, I am a little bit down about that, but at the same time, it's like, that's usually how it is. I bet you guys, like, when you study, you probably face that a lot, especially if you do love the subjects as much as you feel inside your inside your heart. Like, cause, like, I'm pretty sure, like, many of you that are watching probably love math and physics, and you probably are like, wait, why did I get this problem wrong? That doesn't make sense. I thought I knew what to do, and apparently what you thought you knew was probably not the right approach. Which just doesn't mean you're wrong. It just probably means that you thought an idea would work, but then there was something there that you probably weren't counting on, and then you're like, oh, whoops, that's not how it goes. But, you know, that's how it goes. That's how it goes. Okay, guys, I think we're going to conclude stream right here. Thank you for joining me today. If you're watching this on YouTube, you know, drop a sub if you can. If you're watching this, like, after it's been, like, after the live stream is, like, ended, you know, like, drop a comment as well, and like the video if you can. But if you're watching this on Twitch, you know, drop me a follow. It really helps me out with the channel, and putting out more math content for you guys is basically, like, even though it's like a struggle, there are times when it's a struggle stream where I'm basically just constantly getting stuff incorrect. I still post it because it's like, you know, I think a lot of people expect, like, mainly teachers to post, like, stuff on how to do math, but not really, like, their journey on how to get there. And I think for me, like posting my journey with math, you will see me get a lot of stuff wrong, and I think that's just as important as you know, like posting whenever I succeed in math, so as well as physics as well. So hopefully you guys got at least something out of it, like basically like maybe like something to help you like study more efficiently. And maybe you guys got the problems right, and you're better than me at that. So hopefully you did. And if you did, you know, put it in the comments down below if you're watching this on YouTube. But yeah, thank you for joining me today, guys. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys tomorrow for the next stream. So take care, guys. Bye-bye.